Hello and welcome to this session. In this session, we will learn about Sqoop. So there will be series of tutorials on Sqoop. Before we get into the hands-on section, so let's understand what is Sqoop. Sqoop is basically an integration tool connecting the RDBMS and Hadoop. So you have your traditional RDBMS like Oracle, you have MySQL. So what Sqoop does is it can connect to this Oracle or MySQL or any RDBMS, and it can import the data from here and it can put it into the HDFS. So using Sqoop, you can import that data. Now the reverse is also possible, it's also available. So Sqoop can also export the data from your Hadoop system into the relational databases. Now why is that we have to move the data from your traditional databases to the HDFS, right? Most of the projects who getting into the big data, and in order to have the data into the HDFS, you will have to do an import from the traditional systems into the HDFS. So this is where Sqoop comes into the picture. So what are the features of Sqoop? Sqoop can handle huge amount of data, right? When you are dealing with big data, you expect the data to be huge. So Sqoop can handle humongous amount of data. It uses a concept of multi-threading where basically you have multiple processes running at the same time. This would make the process to complete faster, and this is basically the concept of parallelism. It runs, the queries runs in parallel, and it can import all the data at once, and it also can import a portion of the data. So if you have a 10 GB of data and you don't want all the 10 GB of data but a particular section of the data to be imported, Sqoop can do that for you. Sqoop can also work with incremental data. So basically if the data is getting inserted in an incremental fashion, so you don't want to re-import the whole data, rather you only want to import this particular addition to the data, so that incremental load is also possible using Sqoop. It can also do a CDC, change data capture, but this is something that is very rarely used. So Sqoop is big data is mainly used for the analytical purpose, so which case CDC is something that very rarely we use. I haven't seen anything, in fact I haven't seen an export being used in Sqoop, but these are features which are available in Sqoop should we require it. And you can also import it into multiple file formats like serialized file formats that we have seen in the previous section. You can import in those file formats very easily. When you import the data, right, so the data is not stored anywhere. It's not like you import the data stored in some memory, temporary memory, and then you move that data from your temporary memory into the HDFS. So it's not stored anywhere. It's basically a direct flow of data from your MySQL or any traditional databases into the HDFS. So these are the features of Sqoop. So the commands are also very simple. This is a template of the import statement. So we start with Sqoop imports. It signifies that we are trying to import something. Now, in order to import the data from your, let's say, MySQL, you need to first connect to the MySQL. So that's what the hyphen hyphen connect. So hyphen hyphen signifies the different options. So what you see here is a basic list of options. As we move on, progress throughout the course, you will see more and more options being added. But anyways, back to the topic. So if you want to import something, you say Sqoop import. Then you mention connect the JDBC connection. Here we are using the JDBC connection. We give the host name, the port number, and the database names. So with this, it will connect to the database. Obviously, you will have to give the username and password. So M1 is basically, M is basically mappers. It basically tells you the number of parallel process that Sqoop is going to do. Right now here in this case it's just one. Then we give the table name. So table is basically which table that you want to import, and target directory is basically where you want to import that data. So this is a HDFS location. So this is a basic template of the Sqoop import. Now it's very similar to this. We also have the export. Now, if you see here, the only changes are basically the Sqoop export. Earlier we had import. we have the connect, we give the username, we give the password, we have the mapper, number of mappers, we give the table name, then we give the export directory where the data is residing, right? So this is about Sqoop in a nutshell. Now, for this course, we will be using the MySQL database. So we will connect to the MySQL database using the JDBC driver, and we will try to import the data, and we'll also try to export the data. So let me take you to the MySQL database. So here I'm at the edge node. So what I am going to do is I'm going to connect to MySQL. Now the Cloudera that we have installed, it has MySQL database service by default. It also has some data in it. So let's first connect to the MySQL. So in order to connect to the MySQL, you will say MySQL -u. This is user. Then you give the user. The user is basically root here, not Cloudera. Then you give P. When you press enter, it will ask you the password. Password is Cloudera. Cloudera all in lower cases. And now you are into the MySQL database. So if you do a show databases, it will show you the databases that are available. So you got some a few database metastore, MySQL. Some of them are basically storing the log information. So predominantly we will be working with this database. So I'm going to go into this database. So I use a use command. Now the default database at this time is retail database. So if I do a show tables, it will give me the list of tables which are present in the retail database. Categories, we have customer data, we got departments data, we got order items, orders, products. So let me quickly select some data. So let me go with customers. I'm going to limit this to 10 records. So see, this is the data that we have in the customer table. Similarly, let me also check with orders. Okay. Right, so we have this data here. So these are the tables, some of the tables that we have. So using this MySQL, we are going to write our Sqoop commands. So in the next series of videos that follows this one, we will try multiple commands, and the commands that we are trying it or we are executing it will be provided to you in the article section. So you don't have to copy those data. You can basically take it up from the article section. So I hope this is informative, and I'll see you guys in the practical section. All right, so here we are at the edge node. Now what we're going to do is we are going to connect to the MySQL database using the JDBC driver, the passwords and user IDs that we have, and we are going to use the retail_db database, the database that we have looked at. So these are the some of the tables that are there in the retail_db. We are going to use some of these tables and in our examples, and we are going to import these tables. So without wasting any time, let's get started. So for importing the Sqoop command, I write Sqoop import. So this will signify that it is an import. Then I have to specify the connect identifiers. Now I have to connect to the MySQL database. So I'm using the JDBC connector here. We are on localhost and the port is 3306. Here we have to specify the database that we want to connect to in MySQL. So here it is retail_db, and then we have the username, which is root. Then we specify the password, which is Cloudera. We specify the number of mappers. Here let's start with 1, and then the table. What is the table that we want to import? So we want to import the customers table, so we specify customers. Then we specify where we want to import this table. So this is the directory in the Hadoop system. So we want to import this data into this particular directory. So this is a data import, let's say example. So when I press enter, it will execute this Sqoop command. So it will query the database, it will query the table. So if you see the log here, so it is doing select star from the customers table. So it is going to run this query on the MySQL database on the table, and the data it will fetch and it will store in the specified Hadoop directory. So let's wait for this query to get complete and then we'll verify this data. Alright, the command is executed now. Now let's look a closer look at the log. So now when you trigger a command, behind the scene a map reduce job will run. So map reduce will run this and then you will get the result. Now as we know that map reduce has two phases, one is a map phase, the one is the reduce phase. So if you see here, right, we just have one phase. Map is going all the way from 0 to 100%. There's no reduce job that is running. This is because there is basically we have one mapper, there's only one thread, it hits the database, it collects the information. There is no movement of data from one node to the other node because there's only one sequence that goes and hits the database and collects the information. We're not doing any aggregation or anything, so the data movement is not there, hence there's no concept of reduce phase here. The other thing that I wanted to talk is when you run a sqoop command, behind the scene there will be a .java file that gets generated, and that Java file will have all the details that is required for the sqoop to connect to the database. So if I do an lsltr, so this is again in the same place where you are firing this command, right? You can see a .java file getting created. So this Java file will be with the same table name that we are trying to import. So we are trying to import the customer table. So customers.java. So if you do a cat on this, you will see the set of instructions, right? So if you know Java, then you'll understand some of the details. So some of the import commands. So basically these are the column names of the customers table. So all those fields and some other validations and other stuff that it does, right? Anyway, so this is the instruction that it takes. So now let's go back and check this data where it is stored, right? So our target directory is this one. So what I'm going to do is I am going to do an hdfs command to check the data, right? So we'll say hdfs dfs -ls, and this is the directory, and then we will see if there is any file that gets created, right? So we have two files here. So this is a 0-byte file. This basically as you can see, it says _success. This means that the command that is executed is successful. So that's just kind of an indication or you can call as an acknowledgement. This is a file that got created, part yum 00000. So this is a file that got created and the data will be available in this file. So what we'll do is let's go ahead and query the data or just cat the data in this. All right, so this is the data that we have in the file. So all the way we have 124,035 12435 Laura hot, and that's the final record. So let's just verify it. So I'm going to do a select query on the customers table just to verify that the data that we received all the data, or is it some part of the data is missing, right? Just a double check. So we have this many records as the same record that we have. If you verify this is the last record that we have here. So all the data is basically available here. So all the data is basically available here. So there's no loss of data. So we have successfully imported the table data from MySQL into the HDFS. Now, if you see here, right, all your columns are separated by a comma delimiter. So that is the normal default delimiter that it comes up with. So when you import the data, by default, it is stored in the comma delimited format. We can change this delimiter as well, that we will see at some other video. But right now what we'll do is we're going to execute this command one more time. Okay, so this is a command that we have executed. So we will execute it one more time. Now, why we are trying to execute one more time? If you see here the target directory, so this is the target directory. So the data is already present in this target directory. So once you execute this, what is going to happen? Is it going to overwrite the data, or is it going to fail, or is it going to just append the data? So we just wanted to figure that out, right? Right, so this is already done, and here is the error message. So there's an error, it says file already exists. right? So it is not able to overwrite or append because we haven't mentioned anything there. So what we will do is we will append the data. If the file is already present, then will append this data. So here one small change we have to do, we have to add another option, and we simply say append. That's it. So when you say it, when you add this option, it is going to append the data to a directory if it is already present. So these are small changes that we have to do to the original scoop command that we have seen in the template. So this is that easy. So let's go ahead. So let's wait for this to get executed, and then we will verify this data again. All right, this command is also executed. Now what we'll do is let's go ahead and check this directory. Now you should have two files here. Earlier we had just one file. So now because we have appended this data, you should see two files here. Right, you can see it here. This is a new file that got added, and you can see the version, it's 00001, and you can also see the timing difference here, right? So this is how you are going to append this data. Now what if we want to overwrite this data? So for that, what we have to do is first let's remove this is not append. We don't want to append this. Now what we will do is we want to delete the data which is present and then insert the new data. So that's your override. So for that, we give the option delete target directory, dir. This should be target, right? So this is going, what it is going to do is it is going to delete that files which are present. Like we have two files, it is going to first delete that file and then import the data from the SQL MySQL, and it is going to create a new file. That is, it is going to overwrite the existing data. So that is what it is going to do. So let's wait for this command to get executed, and we will verify this data one more time. Okay, so the job is now complete. So let's go ahead and check this directory one more time. Now this time, instead of two, we should have only one file, because we have overwritten the existing directory or existing files. As you can see, we have just one file, and it is the initial version with all zeros, right? So this is how we do a simple import command. So in the next few video tutorials, we will see different options, different ways of importing, and then we'll also see export. I hope this was clear, and I'll see you guys in my next class. Hello and welcome to another session on Sqoop. So this is the last query that we have executed, where we are trying to import the data from the customers table into this particular location. Now here, if you see, we have just one mapper. So right, so this basically means that there will be only one process, one single thread which is going to do all the tasks. Now there is no parallelism here. We can divide this, like let's say if I keep it as 2, what it will do is it is going to create two separate process, and it is going to separate process, two separate threads, so they are going to work together. So basically it's like you dividing that work, entire work, among two different mappers, which is going to increase your execution speed. So let me change this. Now when you increase the number of mappers, you basically saying that, hey, you know, here's the data that is there in the table customers. Now you have to split this data among yourselves. Like there are two mappers, so mapper 1 might take this much amount of data, the other data mapper 2 will take. So how does they do the split, right? So that is something that we have to mention here. We have to use something called a split by. And how do they split by? Usually we specify a primary key column. So here we will say customer ID. So we are saying, hey, go ahead and split the data among yourself using the customer ID, whatever the data. So maybe customer ID number 1 will go to map 1, 2 will go to map 3, you know, it can go like this. So let me go ahead and execute this. Now another thing to remember, or another thing that I wanted to point out is, suppose if you have a primary key column in the mapping in the MySQL table, the original table,
by default, if you don't specify the split by, it is going to take the primary key column. So here in our case, we don't have to even mention the split by column, because it will by default is going to take the customer ID. And if you do not specify the number of mappers, by default it is going to pick 4. So if you don't specify -m option, it will going to take 4. If you don't specify split by option, it is going to take the primary key column. But it is a good practice to mention explicitly the number of mappers, the split by column, so it's easy for other people to read your code, right? So that's very important. Even though it has its default values, it is always advisable to use explicitly mention this, right? All right, so the command is now executed. So let's go ahead and check this data. Now we have mentioned mappers as two. So you should see two different files that are getting created. So you can see here. There are two files that got created. This is file number 1, file number 2. Basically, that is because we have set two mappers. So in parallel, two different queries would have executed, and then those queries would have took the data and in parallel created the files. So let's look at the log. So this is a log that got generated. So if you see here, right, this is something like min or max, right? So basically from the customer ID, it is taking the minimum customer ID to the maximum customer ID, and then using this, it is splitting this data into two mappers. So you can see is the number of mappers too. So 1 2 from 1 to 1 2 4 3 5, this much data is getting split into both these mappers. So that is how the split happens here. Now we have also mentioned that when you execute this query without the mappers and without the split by column, by default it will take the number of mappers as 4, and it is going to split based on the primary key column. So let's test that theory. So I have removed the number of mappers. I have also removed the split by option, and we are again using the delete target directory. So expectation is that the command will execute successfully, the target directory files will be deleted, and then new data will be inserted or new files will be created under the same directory. Because this customers table will have a primary key, which is customer underscore ID, split will happen on customer underscore ID, and then the number of mappers by default will be 4. So you should see 4 files present in the directory. All right, the command is now executed. So let's check this log here. So somewhere here, yeah, you can see here, right, how it is splitting. It's using the minimum and maximum of customer ID. That is because it's the primary key column in the table. So it is taking that primary key column to split this data. And the number of splits is 4. Basically, that's the default number of mappers that will turn up. So let's go and check this data. So we have 4 different files. So because by default 4 mappers have executed, so this is expected, right? As we mentioned, when if you don't specify the number of mappers, by default it is going to pick 4. So basically 4 different processes are running at the same time, and then it has split the data among itself and it has created its own file. So the more number of mappers that you have, the number of parallelism will be more, and therefore your job will be that much faster. Again, it will only make sense if you have huge humongous amount of data. Now the question is like, how many number of mappers can we go, right? So that's always a big question. Can we go for 20, 30? So basically your map, when you take the number of mappers, it's, if you place one mapper, it's basically one connection or one call to a database. Now if your database is getting called from everywhere else, then it may not have that sufficient calls, it may not have that resources to allocate to you, right? So in that case, if you go, let's say your database has 64 resources that you can call like at a time, right? So there are some jobs outside your project calling the same database, and right now around 60 calls have already been in progress. So now even though you give 8, you cannot utilize 8 because there are only 4 left. So that's something that you have to keep in mind. It's not just your job that runs, it's so many other people's job that runs, and therefore you have to be very clear how many calls that you can make. And again, this is something generally we go for 4, but then if it depends, again it depends upon a lot of factors. As I mentioned, if you have a lot of calls available, why not utilize it, right? So that's one of the performance improvement technique here, the number of mappers. Another performance technique could be this one, right? So if you see in the log, this says this transfer can be faster if you use hyphen hyphen direct. So let me give you back. So this is my query. So what we are trying to do is we are trying to connect to this database using a MySQL, using a JDBC connector. Now what it is trying to say, instead of connecting a JDBC director, so you can give another option called hyphen hyphen direct. It will basically use the native directories that are available, right? So whatever native directories or native connectors that are available for that particular database, it will use those database, those drivers, not the third party connectors like the JDBC. That way it will be faster, right? So that's also one of the techniques that you can use. Okay, now what will happen if you don't have a primary key and you're not using a split by, or you are not mentioning the number of mappers, right? So in that case your query is going to fail. So it's going to fail saying that there is no primary key or something like that. So you can try that. You can create a table with no primary key and try to import that without mentioning the split by key, right? So that's it. That's all I wanted to cover in this session, and I'll see you guys in my next class. Hello and welcome to another session of the Sqoop series. So in all our previous examples, we have imported the data. Now we have imported the entire table data. So whatever columns, whatever number of rows are present, we have imported all those data in entirety. Now this is not always the case, right? Sometimes we may want to import just a portion of the data. Maybe a table has like 10 columns, but we are only interested in 2 columns, 3 columns. So we just want to import only those 2 or 3 columns. Sometimes we want to import all the columns, but then we want to filter the data. Let's say we want to import only those data belonging to a particular state or belonging to a particular country, right? So in all these cases, where what we are saying is, instead of importing the table as a whole, we will only import a portion of the table data. This is possible in Sqoop, and for this purpose we have two options. One is using a where clause. Here we basically specify the condition, basically a filter condition. Now based on this filter condition, it is going to filter the data and only that particular amount of data will be imported, very similar to the where clause in our SQL. The second is called as a free from query. Now instead of a simple where clause, we can write a query, something very similar to how we would write an SQL query. So we can do all the joins and everything in that query, and then we, whatever the result that is coming out of that query, only those data will get imported into the Sqoop, into the HDFS. So let's see this in action. So here is the MySQL database. So we are in retail underscore DB, and these are the tables that we have. So let's look at one of the table and see how the data is. So we have been using the customers table. So I'll check the customer table. I will limit the data to 10 records. Okay, so we have customer ID, customer first name, last name, email, password is all masked up, customer street, customer city, customer state, right? So let's say we, instead of querying all the data, we just want the data belonging to, let's say, particular customer state. So before that, let's just check customer state and customer city. So I'll only query this particular data, or maybe I can also add the first name and last name. So these are the tables data for these four columns. So what we are interested here is, let me also limit this data. So we are interested in the customer state. So what we will do is, you can see the customer state, there are different values like TX, CO, PR, C and others. But what we will do is, we will only import the data where the customer state is TX. So that's the data that we want to import, right? So we'll head over to the edge node where we are going to pull in the scoop commands. So I'm going to start with the scoop import, because this is an import, and I have the connect identifier. I am using the JDBC connectors for this. So that's JDBC MySQL. We are running on localhost. This is our port 3306, and then you know this is the database that we wanted to connect, and then you have to give your username and password. Let's take number of mappers as one. Let's take it 2, and the table is basically customers. We don't have to specify the split by here, but it's a good practice. Now why we don't need to specify the split by? Because we have customer ID as the primary key. Anyways, we will specify this. Now this one basically says that we want to import the date table, right, customers from this database, retail database. Now this is where you want to add your where clause. I don't want to import all the data, but I want to import only data where my customer state equal to tx, and put this where clause in quotes. I want to delete the target directory, because I just want to put the new data here. And okay, here we go. So let me go ahead and execute this. This is okay. There seems to be an error. Okay, right. We mentioned delete target directory, but we haven't mentioned the target directory, right? So that option we have missed. So let me go back and correct this. This is okay. This is where you mention the target directory. Okay, now this is going to get executed, and it is going to hit the table, and it is going to apply the where clause, and it is only going to fetch the data. All right, we have another error. What is this? Okay, the safe mode, right? So if you see this, name node is in safe mode, and it's a good thing that we have this error. And I think this is something that I have discussed in the architecture diagram as well, right, when we are discussing about the Hadoop commands as well. So basically what happens is, when you shut down the system, uh, or when you just close the system without proper shutdown, then the name node will go into a safe mode. Now whatever commands you put into the name node, it is not going to accept it, because it's still in the safe mode. So you have to come out of the safe mode. And so we know that the command we have again discussed this, Hadoop dfs admin. So this command will make sure that the safe mode is off, right? So current the safe mode is off. Now let me go back and re-execute this command. I hope there are no surprises now. It should not be, and I think this should get executed very quickly. We have the data. Let me go and check this data. We should have two files created, because we gave the map ss2. So let me check this. All right, so you can see all of them are basically tx, 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 all the data. So only the tx data has been imported. So let me also check the other file. It should also be same. but let's just verify this. It should also contain, yes, all of the data belong to tx, right? So this is how we import a portion of the data using a where clause. Now what we did here is we imported all the columns, but again, let's say we just want to import few columns, right? So we want to add those few columns. So let me clear this first. So this is the command that we have used, where we put the where clause, and we have imported only the section of the data that is satisfying this where condition. Now what I can do here is I can add hyphen columns. So this will specify the columns list that I want. So here I can specify the column names. So I'll put them in quotes. So let me just pick up the column names. What I want is customer first name, customer last name, state and city. All right, this is a small change. We just added the hyphen columns to make sure that we only select few columns whatever we have specified, right? So the command is now getting executed, and it should get completed any time. Alright, so the command is complete, it has executed. Let me go ahead and check this data. So we have used the delete target directory. So the previous command what we have executed, those data is all gone. So you should only see the new data. We have two files. Let me just do a cat on one of them. So you have only four columns. You have the first name, last name, you have state, you have city. You can see all of them are tx, right? Similarly, if you go back and check the other file, you should also see the same similar data with all four columns and just the customer state as tx. So this is how we import the data using a where clause. Now, so this is a command that we have used to query the portion of the data using a where clause. Now another way of doing this is, instead of using a where clause, you can simply use a free form SQL query. Now why we use this option is basically, if let's say you want to generate, or you want to pull the data belonging to multiple tables, you want to have this join conditions, you want to have so many other filter conditions. So using a where clause may not be that simple in that cases, or may not be sufficient, right? So in those cases we can use the hyphen query where clause. Now we're not going to pull any complex queries here, but the concept is that we wanted to understand how to use this hyphen query clause. Again, I'm going to write a simple query. You can try it with multiple join conditions and other things, and try to import this data. So what changes we need to do from the previous query? So we are not going to use this columns, and we're not using the where clause. Instead we are using the query, right? And then I want to write a simple SQL query. I will say select, I would use a customer ID because that's part of my split by, and all your queries should have a from clause. Your SQL queries should have a from clause, right? So we need this data from customers table, and we have to mention something called as and conditions, right? So this is very important to mention. Please don't forget to mention this. So this should be where. Now the reason why we use this and conditions is, so when you execute this query, it has to generate two mappers, right? So the data that each mapper needs to have, that is going to be generated using this. So when you specify these conditions, behind the scene, these conditions is going to have a unique condition expressions, maybe like this many records into this mappers, this many records into this mappers. Let's say we have used customer ID, so maybe all the customer ID greater than 5 will go into mapper 1, less than 5 will go into mapper 2, something like that, right? So this is the one. And because we have already mentioned the table name, this should not be there here, so we need to delete this as well. So this is a change that we have to do. and now it is going to get executed, and it is going to fetch the data, and it is going to put it into the HDFS location. We have used simple query. Again, feel free to use the query, complex query, whatever you want, and get it done. All right, so the data is now available. We use the delete clause, delete target. So whatever the data that you are seeing here is the latest data that has been generated from this query. So we have the same table. We are using the same data. We are querying the same data, but here what we have done extra is that we have added the customer ID column. So we have the customer ID column, and we haven't filtered anything here, right? We didn't apply any filter because we are just pulling all the data from the customers table with customer ID and few other columns. Okay, so let's say here, instead of just pulling all the data, we want to add a where clause and pull only those data which is belonging to, let's say, a particular state. Let's say I'm going to, it's very simple. Here we have the where clause. So what we have to do is we have to add this particular condition is, and now this here, this condition should be there as it is, and we have to add and here. Okay, that's a small change. Let me execute it, and now you should have this data along with the where color. So now you can see here, right, executing the SQL query where customer state is equal to tx. Let me go and check the target directory. So this is a command, and we should have two files. So let me go ahead and check the data. All right, you can see here all the data belonging to the state tx is present. There won't be any other data which is not belonging to tx. Right, so this is how we can query the data. We can query a portion of the data. There are two ways. One is using a simple where clause. You just put a condition and query the data. You can add columns list using hyphen columns. Then there is a free from query where you can use a complex queries. So whatever suits best for you, use this, and you try different examples and input this data, right? So I hope this was clear, and I'll see you guys in my next class. Hello and welcome to another session of Sqoop. So this is the output file that got generated into the HDFS layer when we imported the data. Now if you can see here, all the fields are separated by comma, and this is something that we have discussed earlier as well. When you import the data, by default you are basically importing the data into a CSV format, right? Comma separated format. Now this can be changed. If we want to change the delimiter, we can do that. For that we have to make a simple change. So this is the import statement that we have been using. Now this import statement will import the data into a CSV format in the specified target location. So let me change the target location for once. I will say customer pipe, right? So here what change we have to do is we have to use something called as, right here, we have to use fields terminated by. So when you say fields terminated by, this means that all your fields, or that is your columns, need to be terminated or need to be separated by the delimiter that you specify here. So I will go with pipe. So this way I am telling this sqoop command to make sure that my fields are terminated or my columns are separated by pipe instead of comma. Okay, and then how should my lines be terminated? My lines should be terminated by new line, which is slash. Very simple, right? So this is a simple change that we have to do. So if If you execute this, the data would be generated and will be available in the specified location. And now this time, instead of the comma separated file, you should see a pipe separated file. So let's go ahead and check this data. This is a new folder we have created. It should have two files, so let me go ahead and check this file. You see, all the data is separated by pipe instead of your normal comma. So let's also check the other file. It should also have the pipe delimiter. Yes. So this is how you can change the delimiter, import delimiter. Okay, so now this is fine, right? Now let's say before you import something, you want to actually check how the data is. You just want to print the data to see how the data is. Now one way to do this is you can basically go to this MySQL. You can do a simple select query. That way you are going to check, you're going to see the data, right? But what if you don't have direct access to MySQL? You have just Sqoop, but you don't have the MS SQL, let's just say. So in that case, you can actually connect to MySQL from Sqoop using Sqoop eval. So I will say Sqoop eval. Then I have to give the connect identifiers. Again, this is normal JDBC, something that we have been doing. So let me quickly write it down. Okay, now here you specify the simple query. So whatever query you want to execute on a MySQL, you just execute here. So when you do a query here, what will happen is using eval, because the Sqoop will connect to the MySQL database, it will get this data and it will display this data on the screen here. Right, so this is the data. So the same data that you can get when you query the MySQL database. So why is it useful? Because sometimes, as I mentioned, if you want to just check how the data is before you import, you just do a Sqoop eval, and that is if you do not have access to MySQL. And sometimes even if you have access to MySQL, you may not want to open some command line prompt, or you have to open something else, the front end tool. So instead of opening them, you just use a Sqoop eval and just get the data right here, right? So that will be easier. So this is the usefulness of Sqoop eval. So this is what I wanted to cover. I hope you are clear. Small topics, how we have to import these data from another delimiter into another delimiter, and then how we can display this data using Sqoop eval. I hope this was clear, and I'll see you guys in the next class. Hello and welcome to another session of Sqoop. So here we will talk about incremental import. So what is incremental import? So let's understand this with an example. So here we have the data of customer. We have customer ID and customer name. So this is from the MySQL database. Let's take that example, right? So we have around 6 records here with customer ID and customer name. Now when you do a Sqoop import, you can basically do a select of this data, or you can basically query all the data. You can import all the data. So when you import all the data, what will happen is all this data will basically come and sit in your Hadoop system. So this will go and sit here. Now when you do a query, when you execute the query again, the same query, now if you put a delete target table, so basically you are overwriting this data will go and the new data will come, right? So that is one thing. If you append it, what will happen? The same data will go and sit as a duplicate, right? Which, let's say we don't want this. Now what will happen if you have this data here? After you import this data, you have couple more tables, a couple more records being inserted at the MySQL database. So let's say here 1006 is the last record that we have. So once you after you have imported these records, there are two more records that has come up, let's say 1007 and 1008. So these are the two records that have come here, right? Now if you do a scoop import again, what will happen is if you do an override, it is going to import all this data and it is going to replace this data. Okay, so this way you are anyway you are getting all this data. But the thing that I wanted to point out is, why do we have to import all this data again? We have already imported this data up to 1006. We have imported all this data. All we have to do is we just need this data to be imported, right? Why do we have to do it again and again, right? So we just need this particular amount of data, so this data should come and sit here. So even next time when you execute the query again, if new data comes up, it should pick only those data, and if no new data is coming up, it just should not disturb the existing data that is available here. It should be as it is. Any new data that is coming up, it has to import only those data. So this way we are limiting ourselves to not import the whole data. So this way, by limiting ourselves to import only the new data, we are basically increasing our performance, because if the data is like say 1 TB or 100 GB, then importing the same data again and again might be costly, right? And it's also not good practice, because you may write some statement in your query where you want to import when was this data, when was this record imported. You might have the current timestamp, so that gets replaced when you re-import the entire data. So when you import a portion of the data which is like in incremental fashion, that is called as incremental import. Here we are incrementally importing the data, only the newly added data we are importing it, rather than importing the whole data. So this we can achieve using the incremental import option. So this is the command for incremental append. So again, most of them are similar. Like we start with scoop import. We have the connect identifier. So you give the username, you give the password, the number of mappers, the table names, the split by. We give the target. So then last three are the options which are different. So one is incremental append. So this signifies that we want to do an incremental append. Now when you want to do an incremental append, how do you know that the records that are present are new records or not? So you need a comparison, right? You need a column for comparison. So that is the column that we say. So in this case, we have taken customer ID. So normally a primary key column or a date column is good. So a primary key column customer ID, we have taken it. So we are checking this column. So we are saying, we are giving this, okay, this particular column last value is 0. When we say this customer ID last value is 0, it will pick up all the records which are beyond this last value. So when I execute this query, it will basically query the MySQL database as select star from the customers where customer ID is greater than 0. So all the data which is greater than 0 will come up. So next time what we have to do is we have to change this last value to whatever the last value that was imported. So if I say last value is 10, then it will input all the data whose customer value is greater than 10. So that's how you are importing only the latest data, right? So let me just go ahead and execute this. Okay, so this is the command that we have to execute. So let me go ahead and execute. You can see, right, they are checking for customer ID which is greater than 0, because that's the last value that we have mentioned. And it has imported all the value. Now if you see here, right, the last options, it says it's an incremental append. The check column is basically on customer ID, and the last value that was imported is 12435. Okay, so this is the last value that got imported. So let me go ahead and check this. Data. So it is there in customer. And now remember, we are not using delete target, because that's not the purpose of this. We don't want to override it, rather we want to append it. So let me go ahead and check this. So we have two files, and let me check the data here. So the last value is 1 2 3 4 5. Now if you execute this query again, what it will do is it will basically check all the data which is greater than 0, and it is going to import all those data again, which is basically a duplicate, right? We have already imported the data up to 1 2 4 3 5. So we'll have to say this is the last value that was imported. So anything beyond 1 2 4 3 12,435, anything beyond that, import only that record. So those records will be imported and put it into a separate file. Now here in our case we don't have any such records, so it should not import anything. So let me execute this. So if you execute anything, it should not import any data, right? So it says no new records detected since last import. So this way, unnecessarily, if there is no data, if there is no new data, we are not importing it. So this is a good practice. This is good, right? This is how incremental load should happen. So let's try by adding two records into the MySQL database. So I have the insert statements here. I am inserting two records. Basically, I have given a very big customer ID for both of them. So just to differentiate it, right? So let me go ahead and execute this insert statements. So let me do a simple select query. So I have these two records executed. So these two records inserted. So I have these two records inserted. So let me go back and I'm going to re-execute this query. So this time I have two records which are greater than 12,435. So I should only import this scoop command should only import two records, right? So let's check if it is doing that. So you can see here, right, it says retrieve two records. So it has only retrieved those two records which we have inserted, and the last value is again updated. So this time the last value is 99,999. So let me go ahead and check this directory again to see those two records. So I have two more files which has been generated. I think each file should have one record. So I'll quickly check this file. So it has 99,998 record, and I'll check the other file which should have the other record. Great. So this way we are doing an incremental import. All we have to do is we have to make sure that we change this last value. Now this is a very manual process, right? How can you always remember the last value? You execute a command, you schedule it, you can just keep remembering the last value, right? Sure, you can basically export this to another file and then read that file. All those things can happen, but there is a better way of doing this. You can create a scoop job, you can give it a name. So what will happen when you execute the scoop job is it is going to execute the import statement which is associated with that scoop job. Now this import statement is going to be executed. It will have the last value. The first time you have to give a last value, the initial value, and then once the scoop job is completed, the last value that is generated basically from the log here, that last value will be stored in the meta store. Now the scoop will refer to that meta store, and then it will replace that last value with the one which was stored there. This way we don't have to remember anything, right? So this is a great addition, correct? Just jump ahead and create this scoop job. It's quite simple to create a scoop job. So this is our scoop import, right? We have the scoop import here. So this is a query that we want the data, we want the scoop to execute on the table and generate this data. So So we're not going to make any changes here, so it should be as it is, except that we want to start all over again. So we will say this value is 0, and then what we have to do is we have to create a scoop job on top of it, right? So here one small change that we have to do is between scoop and import there has to be a double hyphen. Now remember, there has to be a space between this double hyphen and import, right? So this is important. Now we say scoop job hyphen hyphen create my job is the name of my job which will be created. So this is the scoop job. So let me go ahead, or before that let me just change this directory. So we were using customer ID, so what I'll do is I will change this to customer underscore job, right? Okay, let me go ahead and execute this. So a scoop job is basically created, right? Now you have to execute this scoop job. Now when you execute this scoop job, what will happen is internally this scoop command will get executed and that data will get stored. Okay, to execute the scoop job I should say scoop job execute exe, then I have to give the scoop job. What was my scoop job? It's my job, right? Yeah, it's my job. So let me go ahead and execute. So it is asking for a password, so I'll give the password, and the scoop job is now getting executed. All right, so it has retrieved 12,437 records. So those are the records which are available in the MySQL database as of now. So if I go back and check this target directory, I should see all those data. So I'll do a simple HDFS ls to see how many files, and we got 2 files here, and if you check these files you should see all the data that are present in the MySQL database. So you have 12,435. Then if you look at this mapper, you should have the remaining 2 data. So this is fine. So what will happen if I execute the scoop job again? So let's just check that if I execute the scoop job, so it simply says there are no new records since the last import, right? We didn't mention anything right here. We didn't mention the last name, we didn't mention the last value, but still it picked up the last value from the meta store. So let's do one more thing. Let's just add 2 more columns here. So I'm going to say I'm just going to add some random values. The only change I'm doing is on the customer ID because we're not worried about the other columns data. We just wanted to check if the data is getting imported properly or not. Only those 2 column data, only those 2 data. Okay, so we have this 2 data. We have imported this 2 data. So I'll go back and execute my scoop job again. And this time what it has to do, it has to pick up only those 2 new records which was just created, and at the same time we have not used the last value. So this is very important to remember. We haven't specified the last value. That last value is basically something which is picked up from the metastore. You can see here the customer ID greater than 99,999. So that was the last value which we got while executing the scoop job before, right? So again, only 2 records have been imported, and that is because of this particular condition where this is the last value that it is getting picked up. So this way it is remembering the last value and it is only executing those particular last value here. So this way we are able to import the data in an incremental fashion. So you have the 2 new records here. Okay, so this is great. Now, if you want to check the metadata of the scoop job, so you can say scoop job show. You give the name of your job. This, in my case, it is my job. So it will give all the details here. So you can see here, right? The target directory, if the table is existing, what is this incremental mode, is this append mode, and somewhere here you should also see the last value. Right, so incremental last value, so this is the last value that is getting updated. So scoop is going to use this data from here, and it is going to replace this particular data with the scoop import command that you have given. Now, once a job is created, once a scoop job is created, you cannot edit the scoop job. You just have to delete that scoop job, and then you have to create a scoop job. That's one of the things here. And if you want to see the other scoop jobs that are present, you basically put a list, and it will give you all the list of scoop jobs that are present, available jobs. Right now there is only one job, and if you want to delete the scoop job, you can say scoop job delete, and you give the name of the scoop job that you want to delete, and it gets deleted. So if you query to see the list of scoop jobs, you should find no scoop jobs, available jobs are none. So this is how you can do an incremental append or incremental import. I hope this was clear, and I'll see you guys in the next class. Hello and welcome to another session of Sqoop. So in all of our previous examples, what we have done is we have imported the data, we have provided the username, but we have also provided the password in test format, right? So if you look any of my previous comments, you will see username as root and password you have given Cloudera. So your password is basically exposed. It's not a good practice, but I have seen these things in the projects in real time as well. So let's say you have a shared user ID and password which everybody in the project is using, so that time you can basically, it's, people would say it's okay to expose that password because anyway anybody can use it, everybody is aware of it. But however, still it is always a good practice to make sure that your password is not provided in the commands or in the code. So what we can do here is there are two ways of storing this password. One is basically you can have the password stored in a file, then you can also have the password encrypted. So what we will do is let's store the password into a particular file. So echo hyphen n Cloudera. So when you do this, it is basically printing the password, whatever store data you have. Now hyphen n is basically to make sure that there are no new lines. Okay, your password should not have any space, it should not have any new lines. So I am going to store this password in home Cloudera. I will create a file, maybe my let's say pass file, simple, right? So if you do a cat on this pass file, you should have this Cloudera password. Now when you use a scoop command, you can basically refer to this file instead of exposing the password. So I'll write a very simple scoop command. So here's a scoop import, and I want to connect it. This is my JDBC. We will use a retail DB. We have to give the username here, which is root. Now here generally we will say password, right? And then we give the password. Instead, what we'll do is we will say password file, and we give the file. So the file is here in the edge node. So we give file and then 3/. This is where the password file is, and then we just give the other details. Let's just do with one mapper, and we are importing the. So we will store this here in data underscore import. So this is the target directory we will be using. So here we have not mentioned the password, rather we have used the password file. So let's execute this. Okay, it says this directory is already existing. So what we can do is we can delete the directory using delete directory, or I'll just put another directory for this purpose, right? All right, so the data is now retrieved. It has retrieved all this data, and if you can go ahead and check this data, right? So I have the file here. So we have used just mapper as one. That's why you will only see one file. So this way we can import this data. We can connect to Sqoop without exposing the password. So we store the password in a file, and then we have given that in the command. Now you may have a question like, hey, you have not exported the password, but then again you have mentioned the file name where the password is stored. What if people can go ahead and check this password? Yes, that is a possibility. Now, so what we can do here is, for this file we can give permissions to only certain individuals who really require it. So if you are the person who is going to execute this command, you should have the permission for this file. You should also have the permission to this scoop command. Similarly, if there are other members of your team, only those people should have the permission. Any other person who is not supposed to execute this command should not have this permission. So this is how you can control how your password can be retrieved. You're basically restricting your password to people who really are authorized to use it. Now there is a better way of doing this. So what if instead of storing the password in test format, we store it in an encrypted way? Using with this, what will happen is, even if an individual who is not authorized to use this password, if he has access to this file, he will only see the encrypted password. He have to decrypt it to use it, right? So it's a lot more secure. Now we can achieve this in Sqoop. Sqoop supports JKS to store the passwords, which we can be encrypted, which they can be encrypted. So now this JKS is basically a Java key store, is a repository of security certificates. So it either is for authorization or public key transfer. It also has some private keys and other things in the encryption format, right? Now we're not going to cover what JKS is, what are the other features of JKS, but if you want to understand about this, feel free to Google. There are a lot of good documents or good articles on this, but we will limit ourselves to Sqoop. So we need to use this JKS to encrypt the password. So there are three steps here. So first step that we have to do is we have to create an encrypt password. So we use this command JSX, and then this is the HDFS location where you want to store the password, right? And once you create this, it will ask you for the password, and you give your password. Basically it will encrypt the password and it will store in this location, HDFS temp, whatever the location that you specify. You can cat this location to see how the file, how the password is. It won't be in a text file, it will be in encrypted format. Now this particular format, this particular file, you can use it. Now if you see here, right, this is an alias that we give. So this we don't even have to give this location, we just give this alias. So the alias here is encrypt password. So if you see this Sqoop import, so this is what we have to put. This line of code is basically to check the provider, the path where we have the JSX my password, then we have the connect identifiers, and if you see here, right, instead of password you're using password alias encrypt password. So this is the alias that we have created here. So this way we will be able to use the encryption. So let's go ahead and start this. So I have the commands here. So the first thing is basically to create an encrypted password. So the path is here, but then your password will have an alias. So you can refer to this path, or you can also refer to this alias. So when you give this alias, it will basically refer to this path. So I'm going to copy this, and let me clear this up. So we have to give the password. So my password is Cloudera. Just for confirmation, it is asking. So it says that password has been successfully encrypted. So this is the alias that we have. So let me just do a cat. So this is how your password would be. As you can see, this is all in encrypted format. So even if you give this password to an individual, he cannot use this, right? So you'll have to decrypt it. Now let's go ahead and use this password. So I have the Sqoop import. This is where we specify the path where the file is, where the password is. And then instead of using the password file or password name, we use the password alias. So this is the encrypted password. So if I go ahead and execute this, this should execute and it should be able to run smoothly. So it has retrieved all those records, right? It has retrieved the records, the data is retrieved, and we have not even mentioned the password file name, or we have not even mentioned the password. So this is a more secure way of doing the password. So you can use this encryption and then you can secure your password. So this is a good feature to have. So if your projects are using the passwords by just storing it in a file, or maybe you're just exposing it as it is, so instead you can recommend this is a better way of storing the password. And anytime you want to, you change the password, all you have to do is you'll have to re-execute this first command where you are encrypting the password and give the new password. This way you can refer to the updated password. So this is what I wanted to cover. I hope these things are clear, and I'll see you guys in my next class. Hello and welcome to another session of Sqoop. So what you see here on the screen is basically a simple import statement. So we have the retail DB under which we have a table called as orders, and we are importing this into a target directory. We are just using one mapper here. So let me go ahead and execute this. So we have 68,833 records which are executed or which are imported, and if you see here, right, there is no reduce job that has happened, because basically there's just one phase where you just connect and import the data. There is no concept of shuffling. So this is one thing I want you to remember, because this is something we're going to talk about in just a few minutes. Okay, so anyways, let me just go ahead and check this data. So we have this data in just one file because of one mapper. So I'm just going to do a simple cat command, and we have all this data. So let me take you to the MySQL database. So this is the table that we have imported. I have picked some records, 4 records. So what we want to do is, like in earlier classes, we have seen how we can incrementally import this data, right? So if a new record is present, then we can incrementally import this data. But what if in the existing data there are some changes? Say for this order ID, currently the status is on hold. What if it changes to complete? Similarly, if it is closed, if it is going to on hold, right? Now when you do an incremental append, you will not be able to get this data, because it's not a new record, it's an existing record. So we want to get all those records which have changed. So this is basically something which we can achieve in Sqoop. Now this kind of scenario are very rare. To be very honest, I have not seen this kind of scenario, and it's most likely that you will not be seeing this kind of scenario, because HDFS or Hadoop Big Data is not for transactional data, guys. So this is basically, if you're using your normal relational database, this is kind of frequent occurrence, but you will not see this thing in the Hadoop system. But anyway, this is a feature that the Sqoop provides, and in rare scenarios you might see. But let's see how we can achieve this. So basically what we are saying is, we want to retrieve the data of records which has changed, right? Now for that, what we'll have to do is we have to identify the column which using which we can say, hey, you know what, using this particular column I'm going to compare the data which is there in HDFS to the data which is there in your MySQL. So a primary key column, so let's say your order ID, right? So your order ID is here in the Hadoop, your order ID is there in the MySQL. So what will happen is the order ID in each of this Hadoop and your MySQL, they are compared, and using this as a primary key, it will go and check if the data is changed between the Hadoop, like the odd for this particular order ID, let's say for this particular order, is there any change on the order date? Or for this particular order, is there a change in the customer ID or order sheet? If there is a change, which basically means that something has been modified, so that particular record, it will import it and it will update it. So this is how we can basically make sure that we have the latest data, or the data is synced between the Hadoop and the MySQL. So before that, what we will do is we will have to update some data because we have already imported this data. So we will update this data. So this is the data that we have. So let me go ahead and update this data. So I just updated each of this data. So basically on the order status, I am giving some test values based on the order ID. So if I go ahead and execute this and I check the data here, you should find the new values like test one. This is easy for us to identify this data. This is what we have updated. So let me go ahead and commit this data. Now we will go ahead and execute the scoop command. So let me clear this up. So this is a scoop command that we have to use. So this is basically something that we have already know. Username, then we are taking the password from a file, table name which should be order. So let me go ahead and change this. And this is a target directory. So I think this target directory should be orders. Okay, let me change this. And then incremental last modified. So basically we are saying this is an incremental, but instead of append we are using last modified. The check column is order date. So basically this will tell you like within this order ID which is used as a comparison. So we mentioned this here, merge keys based for comparison. So it is used for comparison, but it will not compare all the values, right? It will only compare the values which are basically changed after a particular date. So you give the order date here. So it says from 2014 0515, whatever the values that has been changed, I will only take only those values for comparison. So let's say let me take you back here. So I have these values. So these are the order date, right? So this order date, so we have 2014, we have March, then we have April, then we have 6, right? So what it does is it will take, anything which has changed from 2000, I mean 0415, I will only use those for comparison. So it, even though there is a change in this the first two records, but because it does not fall within the value, the order date which we mentioned, it will not use for comparison. So that's what it means by last value, right? So let me go ahead and execute it, and then once we see the data, it will be a lot clear. Now if you see here, right, we also have the reduce phase. That is because the reduce phase, we want the data to be shuffled. The data gets shuffled because you have to do this comparison, right? So use a merge key to compare this data. That's where this reduce job is invoked, and it just gives you the last value which is updated. So it is just saying that, hey, why don't you create a scoop job, because you don't have to remember the last value here. So that's a good suggestion that your log is giving you. So anyways, let me go and check this data. So I have this data here. You can also see the naming change here. So let me just show you. So here it says part R. R is for reducer. If a reducer job is involved, then it will have this R. In earlier cases, we have seen this name as part hyphen M. Not that it is important, but just to check whether it's a reduced job is involved or just is a mapper job. So what I'll do is instead of checking one by one, I'll do a grep, and I'll just grep for those order IDs that we have, right? I'll use maybe what was this order ID. Okay, I six. Okay, I think I can I'll copy it from there. I don't remember exactly. Okay, so this was one, two. All right, I'm just grepping these values. Okay, so you can see here, right? So these two values 68809, they did change, right? Even though on the SQL side we have changed this, but it didn't change. That is because the last value that we have given is basically greater than this. We have given 2014-05-15. If you see our query, where was this last query? So our last value was 2014-05, so 2014-04-15. So all the data beyond this is the last value, beyond this will be compared. So because this does not fall in that range, they are still not changed. But if you see here, this is 16, date 16, beyond 15, then this is 28, beyond 50. So these things have changed. So this is how the last value works. So once you have this last value executed, only those, it will basically compare only those data which falls beyond this last value, and then it will use a merge key that is used for comparison. It will compare, hey, for this order ID, did any of the columns change? If it changed, let's change it at the HDFS side. Let me just do a head here. Now this is the first record, it does not have any header. So how will Sqoop know that you have to check this particular column, this data with the date value, and this data with your status? Why cannot it be like, hey, it will just check the order ID with this particular column, right? How does it know? Because we have columns here, but we don't have columns here. So how it works is, it does not work with columns. Basically it will check your columns position. So here the first position is order ID, so this value it will check with the first position here. Similarly, the second position is here, it will check the second position data here. That is how it is going to check. It is not going to check based on the column name, but based on the column position. The first column from MySQL is checked with the first column from HDFS. That is how the comparison happens. Okay. So your HDFS file and your MySQL database should have the same table name. It should have the same and it should have the same structure, and the column name should be in the same position. If your HDFS has the column names not in the same order as that of your MySQL, then there is an opportunity that it might fail, because you might go ahead comparing your string with your date or your date with your number, then the Sqoop will throw an error and it will fail. So make sure that the column structures, the table structure, the column positioning is all same between the HDFS and your MySQL database. Okay, so this is what we wanted to cover in this particular section. I hope this was helpful, and this is something that we will not use it that much, but anyway, this is an important feature, and it's good to know this, and I hope you were able to grasp this. It's a very simple concept, and I'll see you guys in my next class. Hello and welcome to another session of Sqoop. So in all our previous examples till now, we have imported the data in a normal text file, right? So we did a HDFS cat and we were able to see the data in your text file. But we have also learned that there are other file formats, the serialized file formats like the sequence file, the Avro file, the Parquet file, the ORC file. We can also import the data in that file format as well. It's quite simple. There's not much of a difference actually. So if you look at this particular command, now whatever that I have highlighted, this is a normal command, this is a normal thing that we do. So if you import like this, if you execute this command, it is going to import the data in a text format. Now if you want to execute this in a sequence way, then you just have to add this particular sentence as sequence file. So you are telling Sqoop to import this data with whatever the username and password that you have and the mappers, number of mappers, but import this data as a sequence file. Similarly, if you want to use this as an Avro, you just use as Avro data file. If you want to do it in a Parquet, you just put as Parquet file. So that it is that simple. Now for ORC, unfortunately, we don't have something like ORC as a ORC, but there is another way we can do it, which we will see in just a minute. But let's go ahead and execute this command. So I'm going to copy this command and I'm going to execute this. Let me clear this up. So I press enter. So basically this is going to execute the command and import this data in a sequence file. So the data is now executed. So I'll go quickly and check this data. So I do an ls to list of the files. So I should have only one file. So if I do a cat, so you will see this data would be in unreadable format. So this is the data that is there, which is quite unreadable. So this is the sequence file. Now similarly, you can also import it as Avro file. So again the same command, except that instead of as sequence file you use as Avro data file. Rest of it is all same. You have the import, you have the connect, you have the username, you have the password file, table names, everything is same, except that the final words is as Avro data. You are importing it as an Avro data. All right, so we have this data here. We have imported it as Avro file. So let me quickly check. So you can see the extension .avro. So this is an Avro file that we have imported into. So again, unreadable format. So this is your Avro file. It's quite unreadable. Okay, so let me do the same thing with Parquet file. So again, the only change is this particular line or this particular code where we have mentioned as Avro Parquet instead of the normal file. Okay, so this is going to get executed and we should have this data in the Parquet file format. All right, it is executed and I'll check this directory where it is stored. So you have this data here. So this is your Parquet. So if I do a cat, again this is in unreadable format. Okay, so anyways, so instead of cat, let's say we will use text. We have seen this as well, right? Especially when it is a compressed file, to see if this is going to show us a little bit more better data. But no, here you can see some data, but again this is again in unreadable format, right? Similar. So text basically works for zip data. So this is more of a compression and other things, right? So this is how we are able to import this data. So we have imported the data in the sequence file. We have imported the data in Avro file. We have imported the data in Parquet file. Now, why do we import this again in this serialized format? Is basically, as we mentioned, serialized data are easy to transfer. So when you using your Hive or you're using a Spark, you would basically want the data in one of the serialized formats, whether it's a Avro or ORC or your Parquet. Again, we have seen the differences between each of them and the use case for them. So it is important that you have the data in the serialized format. Now you could basically import this data in test format and to do some kind of processing to change that into a serialized format, but Sqoop itself will provide it. While you import it, you can import it in the serialized format. Okay, but now what about ORC? Now, ORC, there is no equivalent as Avro data file or as Parquet file or as sequence file. In order to import this file as an ORC, we need to leverage the Sqoop's HC catalog feature. So H catalog, so it's not HC catalog, it's H catalog. H catalog is a table storage management tool for Hadoop that expresses the data of the Hive metastore to Hadoop application. So basically what we are saying is you will have to create a Hive table for the ORC file to be stored. It cannot be just imported, but you have to create a Hive table for that. Now we will learn about Hive in the coming section. We have a separate section where we'll deal with Hive, but basically at a very high level, Hive is basically a tool or a query tool used to query the data. So you have the data in your Hadoop system, and how we are reading this data is HDFS cat, right? So if you want to read the data in a tabular format, you can create a table, not just like a SQL table. That table will refer to this particular file, and when you query this table, you can basically say select star, and this query will go and hit this file system and it will retrieve this data. Okay, so if you are confused with this, that is okay. You can still there is a separate section on Hive. We will discuss in more detail how everything comes up, but for ORC, for the purpose of understanding ORC, what we have to do is we have to do two steps. One, we have to create a Hive table with the desired HDFS warehouse location, and then we have to import this data from RDMS to that table. So when you import this table to that table, behind the scene it is getting stored in the HDFS location that is mentioned, right? So that way you will have this data ORC file in that location, right? So let's just jump ahead and create this. So this is how we import it as a ORC. So we have the Sqoop import where we are connecting to the database, MySQL database. We have the table names, then M1, then H catalog database test. So this is a test database that we are creating. Then the table name that we are mentioning, and then we are saying that stored as ORC file. So this is important. When you say stored as ORC file, the table will be created and then the data will be stored in ORC. Okay, so let's go ahead and execute this command. So let me change it to orders, right? So this is the command that we have. So I just removed the line, so make sure that when you execute it there are no lines. Otherwise you have to specifically mention that this is a new line, right? Anyways, let me go ahead and execute this. So this is going to run. As you can see here, right, it is creating a table, create table test.order. So the database is test, and then it is creating the table orders. So while this is running, I am going to open another session. Okay, now I want to open Hive here, so I'll just type Hive and I enter. It will open the Hive session for me. Meanwhile, we see this, the data is retrieved. You can see the number of records it has retrieved, and if you scroll up and you will see the details related to this log. And what we are really interested here is this one, the create table. So it has created this tables. It looks like a normal SQL statement, right? You create the table, you give the details, and here it mentions like, you know what, this table data you store it in an ORC file format. So, okay, we want this test dot orders. So let's go back. So we are at Hive here. So if I do a show databases, it will list the databases that are associated. So we created this table in test, so I'm going to use this. So if I do a show tables, I just have one table, right? So now I can query this like this, your normal SQL statement. So it will give me the details, right? This is the same data, right? Orders that we have imported. Now this, if I do this, if I execute this query, it will give me the details of where this file system is, where it is stored. So if you see here, this is stored, this is the location, and this table data is basically stored here, user hive warehouse. So this is basically user hive warehouse is the default location of the hive. So I'm going to query this. So I come back here. So if I query here, so you will find this. So this is the file. So this is the ORC file that got imported. So if I do a cat, I should see this is basically the data that is coming up. So this is how we can import this data into the ORC file format. So we need to create a Hive table. The Hive table will have the file system stored in the default location, and you can access this location. That is where your ORC file will be stored. So this way we can import this data. We have seen how we can import in sequence file, we can import in Avro data file, we can import in Parquet, and we can also import in ORC file. ORC file we have to do a little bit of work, but all the others are quite simple. You just add like one word code to the normal scoop command and you should have this done, right? So that's it for this session. I hope this was clear to you, and I'll see you guys in my next class. Hello and welcome to another session of Sqoop. So in all our previous examples, what we did is we imported just one table. So whether we import it as a whole, whether we imported a portion of the table, bottom line is we imported only one table. So if you want to import more than one table, or if you want to import all the tables at once, you can use the concept of import all tables. So basically Sqoop will provide a feature where you can import all the tables at once. So this is the command for importing all the tables. If you see here, right, there are only two changes. First change is here where we are saying import all tables, right, instead of just import. If you have said Sqoop import, that means you want to import only the particular table that you mentioned, but here we are saying Sqoop import all tables. You are importing all the tables. Now the second change is here at the last where we say warehouse directory. So instead of saying the target directory, we are saying warehouse directory. Now why is that? So when you take a target directory, you are just mentioning one directory, but then you have lot of tables, right? So instead of target directory, when you say warehouse directory, it will create this directory. Here it's tables, and inside this directory it will again create one more directory for tables. So if you have order tables, so you will have inside tables you will have order directory, and then inside this order directory you will have the files related to orders. Similarly, you will have customers directory and all the other tables directory. That's the reason why you use the warehouse directory. I'm going to go ahead and execute this. So I will, let me change this as table underscore new, right? So I'm going to execute this. It is what it is going to do is it is going to create a directory here, tables underscore new. Inside each directory, it is going to create a directory for each of the table which is present under retail underscore db. So let me go ahead and execute it. While this is getting executed, let me show the tables that are present inside the retail db. So we have categories, we have customers, we have departments, order items, orders, and products. So we have around 6 tables. So we have 6 tables. So all the 6 tables should be imported at once in a single statement. So currently it is importing the customers table. So this might take some time because we are doing all the imports in the single command. So let's wait for this command to get executed, and then we will verify this data. All right, so we have all the data retrieved now. So if you see here it, right, it is here it says 68,838 records, then it imported the product. So basically, even though you have this one command, so for each table it is executing each command. So it will first execute, let's say, orders. Once it is imported, then it will go ahead and execute the next table. So these things are happening in sequence. So if you can see it here, so this was another table, and this was another table which got transferred, right? Anyway, so let's go and check this warehouse. So this tables underscore new should be created. As you can see, you have categories, customers, department, order items, order. So you can pick any of this and you will see the data present in each of this. So customers, we have this. Let me pick up something. So orders has a file. Let me also check the department table. So you can see you have department. So all 6 tables data has been imported. So this is how you can import all the tables at one go. When I mean one go, in a single command. Now let me go back to this query again. Now here we are saying we are going to import all the tables, right? We have 6 tables, but what if I don't want to import all the tables, I just want to import few tables, right? In that case, what you can do is you can do an exclude tables here. So you can say here, hey, import all the tables, but make sure that you exclude these tables. So whatever the list of tables that you provide here, those list of tables will be excluded. So if I go back, let me see. Let me say I don't want categories, so let me exclude the categories here. And let me also pick up customers. I'll pick the first 3 tables. Okay, okay, so that's it. And let me change this. Let me change it to exclude. So I'm going ahead and executing this. So this is going to take some time. It is going to import all the tables except for those tables which you have put in the exclude tables criteria. So this way, instead of importing all the tables, you can just import only selected tables that you want. All right, the query is now get executed. So let me go ahead and check the location. So we gave tables underscore exclude. So you should see only 3 tables, right? So we have order items, orders, and products only. So we don't have the other tables which were categories, customer, and departments because we have excluded them. So let me quickly check these tables. I forgot to give the name. Okay, so we have this data. Then let's also check this. So we should have this table data being created. So this way we can import this multiple tables, right? So we can import all the tables. We can also import select a table. So whatever you don't want to import, you can put it in the exclude table list as a very good important feature. And again, this is very simple as well. We just made minor changes, right? So in fact, all of the scoop commands, we just make minor changes to the original template that we provided at the beginning of this session. So you can have this template and then you just make a minor changes here and there, you should be good. So that's it for this section, and I'll see you guys in my next class. Hello and welcome to another session in the Sqoop series. So in this session, we will see how we can work with null data. So how do you handle such null data, right? So what I am doing here is I'm creating a simple table called test. It has 3 columns: ID, name, and city. And then I'm inserting 2 records here. One record is basically has null at city. The other record has null at the ID column. So these are the 2 records. So I am going to go ahead and I'm going to do a simple scoop import. This is a simple scoop import that we have been doing. So we have the connect drivers. This is under retail underscore DB. We have username, password. We are using just one mapper. This is a table name, and this is where we wanted to import this data. So I will go ahead and execute this data, execute this query. So it has retrieved the 2 records that are available. So let me go ahead and list this directory. It should only have one file. So I am going to go ahead and cat this. So if you can see here, right, we have this data, we have null here, we have null here. Now the problem here is, if this is basically treated as a text, this is not treated as a null as we know in the relational database. So if you read this data, this particular record will be treated as a string. It's not a null record, it's a string, it's a string value. So when you want to query using hive or any other thing, then you will have a little bit difficulty, because those programs will treat this as a string. Now what we can do is, when we do an import, we can basically convert this. So if it is a null, we can replace it with some value. So here if you see this particular column, which has city wise city column, this is string and this is basically non-string. So what we can do is, we can say, hey, you know what, all columns, all in the table, all the columns which are string, if it has a null value, we replace it with something. If it is a non-string and it has null in it, we replace it with something else. So with this scoop command, what we have to do is, we have to add one simple option here. So I'll change the directory here. Now here what we have to say is, we say hyphen hyphen null string. So if it is a string column and if you are seeing null, replace it as null data. You can do anything, you can put anything. I'm just putting it as null data. However, if it is a null in a non-string columns, then what is the value that you want it to be replaced? I want to replace it with 0. So my ID column, if it is a null, it will be 0 in the final output. My city, if it has null, it will simply say null data. So this way we are basically replacing this data, right? So let me go ahead and execute. All right, so it retrieved root records, and we have this data here in this. So let me go ahead and list this. So while we were learning Sqoop, we are also using the HDFS command, common HDFS command, where we are listing the files, we are catting this file. This way you will also be learning or also be practicing the HDFS commands. Not much, but still these are the common HDFS commands we keep on using. So as you can see here, right, here this was null, but we replace this with null data, and this was a null record, and here it was null in the id column where, and we have replaced that with 0. So this way, while you import that data, if you want a particular null values to be replaced with some other value, then you can use this option. This is quite an important feature, and especially when when you are trying to import this data into an hdfs text file or something, because there everything is treated as string, right? So when you want to read that particular file that you have imported, if you have null in it, null will be treated as a string, which is not the case, right? So that's why it is good you do a cleaning, some kind of, this is kind of a cleaning process where you know kind of identify the null records and replace with something else, where when you query this data, you can add, hey, if you find 0, which basically means that was a null record, that's why we have 0 there, right? So this is something that we can do. All right, so this is what I wanted to cover. It's a short video, and I hope that you have liked it, and I'll see you guys in my next class. Hello and welcome to another session of the Sqoop series. So in this session, we will talk about export. Now, all our examples previously where we were importing the data from MySQL into the HDFS layer, that is what happens most of the time, right? You wanted to move into the big data, you want to move it to the HDFS layer. So you copy this data, you import this data from the MySQL or any traditional databases into your HDFS layer. Now Sqoop also permits us to export the data. So export the data from HDFS into the MySQL. And again, this is something that we don't do it often, and I haven't seen any case where we had to export the data from HDFS into the MySQL. But there is a feature we can do that. We can export the data from HDFS layer into the MySQL layer. So here I'm at the edge node. I have this HDFS location. This is where we have imported some data, so the text null. So what we will do is we will export this data to the MySQL database. So before that, let me go ahead and delete this data, right? We have the data deleted. I have committed as well, so I'll do a simple select star just to verify that there is no data here. This is empty, there is no data. Now what we want to do is we want to export the data from the HDFS layer into this table. For that we use a Sqoop export. So this is the command for Sqoop export. So this is a Sqoop command. So this is a Sqoop export command that we will be using it. So again, 90% of it is same. There's small changes. Instead of import, we use Sqoop export. Then we have the current identifiers. You have username, you have password, table, then staging. So we need to create a staging table. So staging table should have the same structure as that of the actual table. Now what will happen is this particular table will first, the data from the export directory, this is where the data is present, this data will be copied into the staging table, and from staging table it will be moved into the main table. So this is a concept of having a staging table. So the first thing that I want to do is I want to go ahead and create a staging table. So I have a staging table created. This staging table now does not have any data, so it is empty. So now I am going to go ahead and execute this query. Okay, so we have this data. So as you can see that migrated two records from test stage to test. So first data is moved into this test stage, and then from there into the test. So let me go ahead and verify this. So your test stage will not have any data because the command has run successfully. So the data which was temporarily stored in the test stage or staging table has been moved into the main table. So if I query my main table, I should see these two records, which is great. Now the question is, what will happen if when you execute a query, the query is executing, the data is copied from the HDFS location into the staging table, and then it fails, right? So when it fails, the data will still be stored in the staging table. So the next time when you run this command, the data is already present in the staging table. So what if we want to just, before we execute this command, we just want to clear the data in the staging table. So this is kind of a truncate end load. We just want to first make sure that the data is completely flushed out, and then only the new data that we want to import is moved into the staging table. So we can do that by making a small correction, not a correction, but we can basically say here. So here what we can say is we can use an option clear staging table. So what it will do is it is going to clear the data in the staging table before it gets executed, before it moved the data from the staging table into the main table. So this is a good option to have, because you never know when the command will fail, and then your staging table will have some data. It may have some junk data as well because it failed in between, right? So it is always a good practice that we clear the staging table before we execute this command. All right, so it has migrated two records from the staging table. So your staging table should not have any data here. And let me execute the main table, and you will see two more records which been inserted. Two records are inserted in the initial phase. The two records we have inserted just now by running another command. So this way we have exported this data. And again, this is something that is not commonly used, but this is a feature. It's a feature that is available in the Sqoop. So I hope this is clear, and I'll see you guys in my next class. Hello and welcome to another session of the Sqoop series. So we have seen many options how we can import this data. We can import the whole data. We can import portion of the data based on some conditions. We can use a where clause, a free-form query. We can select the few columns. We know how to handle the null data. We have exported the data. We have created the staging table. We have cleared the staging table. We have learned a lot, right? Now let's look at some of the performance tuning techniques that we can use. So we'll divide this into import statements and export. So for imports we use mappers, right? So if you use one mapper, one thread will be created. It has to do all the job by itself. So use more mappers wherever possible, so that the data will be split across multiple mappers, and then your job will be executed rather faster. But make sure that your database is able to accept those mappers, because we have discussed this again, we have discussed this previously. So if your database can only give you let's say n number of calls, right? Make sure that you do not exceed that numbers, because also make sure that you are aware of all the other jobs that are calling this database, because they might end up taking more resources, and your database may not have that number of calls or resources for you to call, and thereby you may actually put in 8 mappers, but then your database might just have like four resources available, and that will basically cause your job to fail. So use caution. Make sure that you give the appropriate number of mappers, right? That is one. And the second thing we can do is we can give a direct option. Now this is again we have discussed in one of our series. So basically some databases will have the native drivers, like for MySQL you have a native driver. In Sqoop the Oracle will have its own native driver, right? So if a Sqoop provides you a native driver, it is better to use, you can use that direct option. So when you give the direct option, Sqoop will use the native drivers to connect to the database rather than the third-party JDBC. So this will have a little bit of impact in the performance, Now we have been using the JDBC drivers because in my course I'm using MySQL, but then you may also have to use some other database like Oracle, Teradata, whatever it is. So those drivers may not be available in Sqoop. Sqoop may not support those native drivers. So in that case, you will anyway have to use a JDBC. So it is better that we practice in that way, so that we practice for all the databases. If you know that particular database has the native drivers associated, then you can use direct option. Other thing option you can say is you can use the fetch size. When you import the data, by default Sqoop will import 1000 rows at a time, right? You can increase this size, 2000, 3000, to make sure that you import more data at a time. At the same time, make sure that you have sufficient memory, because if you don't want to import too much of too much of data that your memory cannot handle. So these are some of the performance tuning techniques that you can try. Again, it all depends upon the number of resources available, the memory that is available. So performance tuning is always trial and error, guys. So in one project your 4 mappers may work, in some other project you can go up to 16 mappers as well. So make sure that you are aware of the jobs, you are aware of the memory, you are aware of other things. And again, this is basically trial and error. So you try based on the ideal situation, and whatever works for you, make the necessary changes. Now, Sqoop tuning for export. So when you do an export, the data from HDFS will be inserted into your MySQL database or any traditional database. So by default, Sqoop can export 10,000 rows at a time. In one single way, it can basically take 10,000 records. Now you can increase this, you can make changes to this property by using this below two properties. One is Sqoop export statement per transaction. The other is Sqoop export records per statement. Now, Sqoop export records per statement, this means how many rows are inserted per insert statement. So here we are saying is 100 records, right? So this basically means 100 rows per SQL statement are inserted. The other thing is Sqoop export statements per transaction. Now this property will tell you how many insert statements are fired. So if you are saying that you are saying 100 statements, so basically here we are saying we are firing 100 statements. So we are firing 100 insert statements. Each insert statement is going to fetch 100 records at a time. So in a way, if you look at this, you have 100 insert statements. Each insert statement will will insert 100 records. So 100 into 100, 10,000. So 10,000 records per Sqoop statement. So that is what the default behavior of Sqoop. So you can increase this, you can make it maybe 200, 300, whatever it is. So that way you are for one Sqoop statement, you are inserting more than 10,000 records. So that is one of the performance tuning techniques that we can do. Okay, so these are very simple performance tuning techniques. I hope this was helpful to you guys, and I'll see you guys in my next class.